In this demonstration, we're going to look at the built-in functions in Excel that allow us to do conditional statements, as well as conditional formatting. In real-world situations, if you're creating a large, complicated calculation, there are times when you do not want your calculations to be continuous. You want to have a discontinuous calculation. This allows your calculation and your formulae to change based on a previous value or a previous result. Real-world examples would include tax calculations. We have separate and set bands at which point different rates of tax are applied. Or, in the case of university, different degree classifications at different mark boundaries. In order to show you this, we're going to set up a quick demonstration. So I'm going to have a test input value, which I'm going to just call test value. And I'm going to give that a value of 20. So B3 is our test value. Now over in D3, what I want to do is set up a conditional statement. And I want to test this value against a set of statements. And these statements will return true or false. Now to do this, we start with our equal sign as normal. And we're going to use the if statement. This is the most basic conditional statement you find in Excel. And a bit like programming, it allows you to have a true or false output. So we start by typing if. Once you've double-clicked on that, you can see that the if statement requires a logical test. And then you can input two different variables that get returned. The first one is the value if true. So if the logical test is evaluated as true, this value is returned. The opposite being, if the logical test is evaluated as false, then the false value is returned. So the first thing we're going to do is build our logical test. In this case, I want to evaluate my B3 value against a set parameter. In this case, I want to test whether it is above or below 39. So I type the greater sign and the value 39. In order to input the value if true, we just put a comma and we move along. And this time I want it to print out the word pass if true. So if value B3 is greater than 39, we print pass. The opposite being if it is below 39 or 39 itself, we print fail. Close the brackets and press enter. So this is now evaluating this statement as false. So it is printing out the word fail. If I increase the value of our test from 20 to a value above 39, let's say 50, and press enter, we're now evaluating as pass. I could bring this value down to 40, it will still evaluate as a pass, but if I go across the boundary to 39, it then evaluates as fail. Now with these conditional statements, if you just got a simple one like this, where it's a single statement, it's not too hard to work out the logic. But just generally, if you're struggling with the logic and you want to test this, you can press your Insert Function button and it brings up the function argument window. And here you can actually see how the logic is working. So currently our B3 greater than 39 is evaluating as false. Therefore, it is coming down to value if false and it's printing this fail, as you can see down here. So bringing up this function argument can be very useful for debugging these statements. Now we can take this one stage further. Say for instance we wanted to evaluate our test value over here against two conditional statements. In this case, we're going to try and evaluate it against the statement, is this value less than or equal to 50? In which case we want it to print out 50. And secondary, we want to evaluate that value to see whether it is greater than or equal to 70. If it is equal to 70, we want to print 70. Any value between 50 and 70, we just want to print out the original value. So to start this, we start with our if statement, and we create our first logical test. So we want to see whether this is less than or equal to 50. If it is less than or equal to 50, we want to print out 50. So if this is true, then 50. If it is false, it means our value over here is greater than 50, so 51 and above. We now want to evaluate this against our next statement. So we start another if statement. This is if nesting. We can choose our B3 value again, and this time we want to evaluate it against 70. So is B3 greater than or equal to 70? If it is, we just want to print 70. If it's not, then this means that it's below 70. And because we've already evaluated over here, we know it's above 50. So the value is somewhere between 50 and 70. So in this case, all we want to do is actually print out this value, our B3 value. So we can refer back to our cell here under the false as B3, close the brackets for this secondary if statement, and then close the brackets of our first if statement. And then we can press enter. So as you can see, this is evaluating as 50. This is because our value over here is below or equal to 50. If I change that value to 50, this should still be 50 over here. If I change this to 51, it's now printing out this value because it's above 50 but below 70. I could type any number between 50 and 70 in here. Let's say 64, and this should evaluate over here as 64. However, as soon as I hit 70, this becomes 70, and as I go further above 70, let's say 77, this will always return as 70. So this is how we can do nested conditional statements. Now there's other ways to create nested conditional statements or statements with and or options within them. So what I'm going to do is just clear out those two examples and show you how. So let's create a statement with an and included in it. So we want to evaluate our statement, our number over here, against two values, and we both want them to be true in order to return the true value. So we start with the if statement. Now here, where it says logical test, what we want to do is have two logical tests, and we both want them to be true in order for the value, if true, to be returned. If either one of these tests is false, then we return the false value. So to start with, we need to bring in the AND function. So you type AND and select. Now this allows you to have any number of logical tests. But each of these tests would have to return true for the actual whole AND function to return true. If any of these tests returns false, then the AND function returns false. So we put in our first logical test. So we're going to evaluate our B3, and we want our B3 to be greater than 40. We then put a comma in. This allows us to enter our second logical test. So we want our B3 to be less than 60. We can close our brackets on our and then put a comma in. So this is the comma separating our logical test in our if statement from our true-false return. So I'm just going to type true and false in our example and close the brackets. So this is completing our function. So when we press enter, what it will do, it will evaluate our number over here, which is currently 77, see if the number 77 is above 40, but also that it is below 60. If it is, it will return true, otherwise it will return false. This should return false, and it does. So if I was to move our input value to somewhere between 40 and 50, this should turn true. Let's say 50. There we go, true. We could do 55 because that's below the 60. We could do 40. But here, because our statement is asking for something above 40, we've dropped below this value, and we're now turning this AND into a false. So it's returning false over here. So that's the AND statement. Now there's also an OR statement, and this works in this manner. So we start the if statement again, but instead of putting AND in, we use OR. And what the OR statement does is it checks any of these input logical statements that you're entering, and if any one of them is true, then the whole OR statement returns true. They all have to be false for the OR statement to return false. So in this case, I'm going to create a conditional statement where B3 equals 40. And a second conditional statement where B3 equals 60. So what I'm asking is our value exactly 40, or is our value exactly 60? So if either one of these is true, the OR statement returns true, and I want it to print out the word true or false. Close the brackets, and that completes our statement. So this is evaluating as true, and that's because we currently have the value 40 over here. If I change that value to anything else, like 41, this becomes false over here. It will only ever become true if it's 40 or 60. If it's any other value, like 59 or 61, it evaluates as false. So that's the OR statement. With the if, and OR, you can create pretty much any logical statement you want within Excel. Next, we're going to move on to looking at conditional formatting. So how do we change the visual appearance of our data on screen based on either values or results within the cells? So I'm going to go back to our creator data, and we're going to look at our diameter data here. And what we want to do is highlight any cell that has a value above 10. As you can see, we've got quite a lot of cells below 10, a couple which are 10 or above, and we want these particular cells to be highlighted. So how do we do that? First thing we do is we highlight the data. This is selecting the cells that we want to add conditional formatting. We then go to our home bar on our ribbon menu. We come across to our conditional formatting option over here. And this will, on clicking, open up this drop-down menu. And it's got a lot of inbuilt rules. These are quick links. A lot of the time you can just use these. So for instance, on this particular example, we want to highlight every value that is 10 or greater. So we can select the greater than option. This opens up this little menu, and it allows us to input a value. So this is the value we're evaluating our data over here against. So in this case, if we want everything that's 10 or above, we could add a number that is just 9.99 recurring. We can then choose how we want this to be highlighted. We've got lots of different options. You can even choose your own custom format from down here and create your own. But I'm just going to choose the green for the moment. Say OK. And if we look back at our data, everything that is 0.9 reoccurring or above is now highlighted in green. And you can add multiple conditional formatting rules onto the same data. So say we now want to have all data that's less than 5 highlighted. So we go to the less than option. In this case, I'm going to say less than 5. And we're going to highlight it. Let's keep it on the red text, say OK. We can now go back and see our data. Everything below 5 is now highlighted in that red formatting. If we want to edit our conditional formatting, once we have some, we can highlight the area we're interested in, come to our conditional formatting drop-down menu, and we come down here where it says Manage Rules. You'll also notice there's a option here to say New Rules and Clear Rules. Now the Clear Rules is quite obvious. It allows you to clear the rules from either the entire sheet or the selected cells. The new rule allows you to make your own custom rules, and we'll come on to that in a minute. For the moment, let's have a look at the Manage rules. This brings up this Conditional Formatting Rule Manager, and it allows us to see all the different conditional formatting rules that are applied to the cells that we've got highlighted. As you can see, we have the two that we've already created. Now from this menu, we can either delete the rules, we can change the order the rules appear, and this is important because sometimes you'll have multiple rules which apply formatting to the same cell. Sometimes you want to stop the formatting of one conditional statement versus another. So over here you have a stop if true. So in this case, if we had a cell that happened to be below 5, we could tell the program to stop coming down our chain of conditional formatting once it got to this point. Again, this is just a manner of controlling which conditional formats apply to different cells. You can also see here which cells it's applying to. It's giving our cells as a range. If we wanted to change the range from here, we can click on this little bar here, and then we could select a new range, for instance. Once you're happy, you can say apply, and it will apply it. As you can see, you can do multiple columns in one go. And each conditional rule does not have to have the same input in terms of number of cells or cell area. I can delete that rule, and it goes. Now, if I wanted to edit a rule, you can click on the rule, say Edit Rule, and it brings up this Edit Formatting Rule table. And you can see that we've got all these options. And first of all, these are the rule types. This is what is allowing you to select your values based on conditional statements. Currently, we're using Format Only Cells that contain, and this allows us to use this option down here. So this is where we're looking at the cell value, and there's lots of other options here, but normally cell value is what you want. You want it to be greater than. Again, you can change what your value you're comparing it to and how you're comparing it. So greater than, and then the value we've inputted. Now that value we've inputted is currently a manual value, but it could equally be a value that we select. Let's say we want it to be the median value over here. Select that, click that back. We're now evaluating all the cells that are greater than our median value from our reference over here. We can say OK, apply, and it updates our data. Now, if we wanted to create our own custom rule, we can say New Rule, and this brings up the New Formatting Rule table. Again, it's the same sort of options we have when we're editing. So we can format all our cells based on their value, and this allows us to have some preset formatting styles, either 2-color scale, 3-color scale, where we can change our scales, and you can change what these value points are, either the lowest value, midpoint, you can calculate by percentile or by formula, by percentage, etc. And again, the maximum you can select as either one of these options. You can have data bars, and these allow you to add extra information to the cells. So if I say OK and apply, you'll see we now have these little data bars. These are showing the value of the cell based on the overall percentage. So if we have the highest value, which is this 15.55096 at the bottom here, you'll see that the entire cell is filled with this blue bar. This is because that's 100%. And then each of these individual cells with the blue bars has been worked out based on that maximum value. Other new rules you can have. We can format our cells as previously described by their cell values, either between, not between, greater than, less than, not equal to, greater than, etc., etc. We can format by rank. We can format values that are above or below averages, etc., etc. More complicated formatting can be created by creating your own format rules as well. So this is basic conditional formatting. And you can apply this to any kind of data. This can be numeric data or text data. Now there's a couple of other functions I'd like to bring in at this point, and these are related to our conditional functions. So I'm just going to move down to this new sheet called Lookup Demo. And in this sheet, you can see that we have a small table of data over here. What we have are the grey boundaries that are used at Imperial. So anything that is 40 or below, all the way down to 0 is a fail. Anything that's 50 down to 40 is a third. Anything that is 60 to 50 is a 2-2. Anything that is 70 to 60 is a 2-1. Anything that is 70 or above is a first. Now over here on the D column, we have something called student mark. And over here we have something called Vlookup of mark classification on the G column. Now the first thing I'm going to do under the E column, E2, I'm just going to add a random student mark for demonstration purposes. Let's say our student has done quite well and has got 61. What we want to do is take this value over here and then look up on this table what grade classification they got. So did they fail? Did they get a third? Did they get a 2-1, 2-2, first, etc.? So how do we do that? Well, you could write a long conditional statement with lots of ifs. So every time you went down an if and into the next nest, you evaluated your value against another one of these values. But we can use something called the Vlookup function in Excel. And this allows us to look up tables of data. So to use this, we type equals and we start typing Vlookup. The V just stands for vertical lookup. There's an H lookup as well that looks horizontally, but we want to look vertically. And by that we mean we want to look down these columns. So Vlookup. The first thing it asks for is the lookup value. And that's the value we want to evaluate against our table of data over here. And that's our student mark. So I'm just going to click our E2 cell. That enters it into our formula up here. I can press comma. And now it's asking for a table array. Now the table array is all this data over here. So what we want to do is just highlight our little table. And as you can see, it's entered in A1 colon B5, so the range of cells. We put another comma in, and it's asking for something called the col index number, so the column index number. And this is the number of the column that it should return once it finds the value somewhere in A. Now the way that Vlookup works is that the lookup value is always looked up against the first column in your table. So in this case, we want to return the second column. So we type 2, referring to column 2 of our table. Now there's also something called Lookup Range. We'll come on to that in a minute, but anything in these little square brackets on our equation, they're optional, so we're not going to use that for the moment. I'm going to close our main brackets and press enter. As you can see, it's evaluating our statement. So it's saying that the student with a mark of 61 should get a classification of 2-1. And this is correct. So it's coming down this table here. It's found 60. And it's decided that our value is above 60, but below 70. So it returns the 60 value. This is what Excel calls the nearest match. So it will always return the value that is the nearest but lowest value within your table. Now, if we were to change our student mark over here, it will reevaluate what class the student got. So let's say our student did particularly badly and got 49. Press enter. It's now reevaluated that as a third based on this table over here. Now, if we did want to change our lookup, so we would only precisely look up these values. So say, for instance, we only wanted to know and look up the value 40, the value 50, the value 60, and the value 70. But the values in between, we did not want to look up. Then we can change our function, put in this extra option in the variables, by default, it's set to true. And this means it's doing its approximate match, or this matching to the nearest value. If we change that to false and tell it we want an exact match, say enter, it will reevaluate, but this time it comes back with #NA, not available. So we can't find in our table the student mark 49. However, if we change that to a student mark of 40, it can now find that, and it will bring back and return the third text. Similarly, it won't find a value of 55, but it will find a value of 60. So using the Vlookup and its equivalent Hlookup, you can do some very complicated searches on large tables of data. And this is quite useful if you want to bring together data for multiple data sets and use it a bit like a database. Now there's a couple more related functions I just want to cover quickly. So I'm going to go back to my creator datasheet. Now say we want to count how many values in our diameter column are above our 10 threshold. So to do this, we can use a function called countIf. So we can do equals, start typing the word count. We can come down here and we find countIf, enter that. It's asking for a range, so this is our range of values. So we select all our values. So from A2 to A26, put a comma in. Now it's asking for something called criteria. And this is our conditional statement. This is how do we evaluate which ones we want to count. So in order to enter our greater than 10, what we need to do is open up two little quotation marks. And inside this quotation mark, our conditional statement will go. And we can start typing. So greater than 10. We can close our brackets. Then we can hit enter. It's now coming through our data here and only counting all the numbers which are 10, or I should say above 10. If we just wanted it to count exact numbers, say for instance we wanted to count how many times our number 13.49 appeared, we could select that. I'm just going to copy that number. We come back here and instead of having quotation marks, we can just put in an exact number. So we want to evaluate our range against this exact number. We say enter, and as you can see, it's returned 1. That's because we've only got that value once in our column. If I was to come to our column here and add our 13.49 several times, I'm just going to copy that and paste it 3 times. You can see that our column counting if statement is now evaluating 3 for our 3 values we have in this column. So that's how you can conditionally count. You can also do conditional summing, and this is using the SUMIF function. It works in exactly the same way. So we can create our range, we can put a criteria in. So say for instance we only wanted to count up the values above 10. So open our quotation mark, say above 10, close quotation, close the brackets, enter. So now it's only counting up the values within this column that are above 10. Now both these sort of COUNTIFs and SUMIF functions work well with numeric data, but they also work with text. So I'm just going to quickly make some text data over here. So we're going to have some apples, and I'm just going to add some random apples. We're going to have an orange. Let's have 3 of those. And we'll have a cherry. And we'll have 2 of those. So here's our data. Say for instance we wanted to count number of apples. So count apple. What we can do is equals count if, select our range, and this time what we want to do is just type in the word apple. Make sure it's got our quotation marks around it, close our brackets, and it will go through and count the 7 apples. So you can use these functions with text as well. Just make sure that the text you're entering over here in your function is identical to the text over here. Excel also has various helper functions that allow you to quickly access data using its positional information. For instance, its row number or its column number, rather than a direct reference such as B1 or E1. The first of these we're going to look at is called the match function. So we can start by typing the word match, and as you can see, it requires a lookup value. Now we're just going to search through our apple, oranges, and cherry column of data, and we're going to try and find where the positional information of the word cherry is within our data. So I'm going to start by typing the word cherry. So that's what we're looking up. I'm going to select this range of data. This is what we're going to be looking through. For the moment, I'm just going to close the brackets. Press enter, and we come up with the number 10. So what does this 10 refer to? Well, if we start at the top of our column here and have apple as position 1, orange position 2, apple again as position 3, and if I just drag those numbers down, you can see that at position 10 we have the word cherry. And this is what this is referring to. This 10 is referring to cherry here, number 10 in our column. However, you'll also note we have a cherry here at position 8. So how do we find that particular cherry and not the cherry down here? Well, we can change how the match function works. If we go back to it and add an extra comma in, we can then add in our options on how it searches. By default, it's always searching on the less than. So that's finding the largest value that is less than and equal to the lookup value. If we choose exact match, it'll go through and search for the first exact match of the word cherry. If we press enter, you'll now see that we have 8 as the value. So it's now picking up this cherry here. So by changing how it searches, we can refine which bit of data it returns. Another useful function, which is to do with position of data, is the offset function. And this allows you to bring data from a cell by referencing it from another cell using offsets. And now this is something that's easier to explain by doing. So if we start by typing the word offset, and say for instance we want to reference the word cherry from this cell down here, the red cell, so cherry on number 8, position 1. But we start with a reference that is K1. So we're starting at this position here. What we need to do is tell Excel that we need to go 1 row, 2 row, 3 row, 4 row, 5 row, 6 row, 7 row, 8 row, 9 rows down. So we put 9 in our row entry, and we need to tell it that we need to go 1 column to the right. So 1. We can close our brackets and press enter. And we return the word cherry. And this is cherry having referenced our K1 and then changed its positional value by changing our lookup number of rows, 9 down and 1 across on the columns. Now we can also do that in reverse. So we do offset, but we have a reference over here on, let's say, 01. In order to get down to our cherry here, what do we need to do? Well, we still need to come down 9 rows as before. So we put 9 in. This time we want to go back several columns. So back 1 column, 2 columns, 3 columns. So we can put -3 in. Press enter, and we return the word cherry again. And just to prove that both these cherries here are referring to our red cherry here. If I change this to cherries, press enter, both of these will change. So this is just another way of referencing data if you don't necessarily have the exact reference cell value, i.e. M3 of the data you want, but you do know roughly where it is in relation to another cell. We'll come across more of these small helper functions as we go through the course.